Hi, I'm Carl Peterson. Welcome back to Carl Makes Things Work. Today we're going to do a 3D printing project.
During COVID, I built these cabinets, and the silverware tray that we have is just not filling up all the space, and I would love to have a solution that makes it easier to load and keep organized.
Okay, so we want to make a tray that holds fork, spoon, knife, etc. These specific ones, so we're going to want to have a 3D model of each of these so that we can go into CAD and make a 3D model of the tray that we want that holds them. I don't really want to use calipers to measure every point along here and then put it into CAD. What I really want is to use technology to get a 3D model of this. Let's see if we can use the LiDAR scanner or the structured light sensor on the front of the iPad to get a good 3D model of these objects.
Okay, on the iPad, we have the 3D scanner app that I found for free. You can go to the LiDAR mode. Oh, this is cool. Kind of some sort of RoboCop view. But it already looks like maybe not a fork shape. Let's see what it looks like once we texture and process it. Ooh, yikes. Okay. It doesn't look like something that we're going to be able to use. We also have a front-facing 3D scanner, which is they call it True Depth, but it's the one used for Face ID. So let's see if we can use the front-facing system to get an image. Okay, it looks like it's doing something. All right, it definitely seems like it got a bunch of points and it's trying to do something with them. Let's see what it looks like from a 3D model once it's done processing here. Okay, a little bit more 3D. Definitely doesn't seem like it's good enough.
Okay, that didn't really work. The LiDAR scanner on the iPad works well for room scanning and maybe some large objects, a car, a couch, but it didn't work for a small object. It looks like maybe a few millimeters of resolution is what you can get out of the LiDAR, and the structured light sensor on the front of the iPad didn't do much better. I think another problem is that these are very shiny, reflective mirror finish, and something like LiDAR sensor is going to bounce light off in a way that it can't really get a good depth and distance. The other thing I realize is for the silverware tray, we're going to stack silverware vertically. So we don't really need a perfect 3D model. We just need a great top view outline. So there's another sensor on all of our devices that might do a much better job, and that's the actual camera. So let's go figure out what we think that the resolution is that we could get out of the camera and take some pictures.
I'm using Scannable to take this picture because these document scanning apps take care of a bunch of cropping, fisheye correction, and perspective for us, and outputs an image at the maximum available resolution. Even though we didn't fill up the whole camera and we didn't use a tripod, you can see that the pixels are able to give us a resolution of close to 0.1 millimeters, which is plenty for what we need. Let's take a picture of the fork now. The ring light helps to get rid of the shadows, and I'm taking a picture from directly above the tines because they're the highest point, and we want to eliminate all the distortion possible from perspective. Okay, this is looking really good. Shaper 3D on iPad is super awesome for fairly simple models like what we're going to do today, and they've been adding functionality. So if you have an iPad and Apple Pencil, I highly recommend it if you're going to be making 3D models for 3D printing. One nice thing about using a document scanning app and putting your object on a piece of paper is that the app knows that it's 8.5 by 11 inches. And so if we type 8.5 in Shaper 3D as the width, you can see it comes in as 10.98899, basically 8.5 by 11, which means that spoon is actual real size in CAD now. And we don't have to do any other measuring to figure out how to get it scaled properly. So let's pull in all the rest of the images. These images come in on the XY plane, so I can space them out and then double click on one of them so that we can start a sketch. The first thing that we want to do in the sketch is to create a midline that we can use to mirror the symmetrical ones for the spoons and forks. So we're going to use the midpoint of a couple of lines that go all the way across the width, and we have to turn off all the snapping so that we can pick any point we want. These points that I'm creating end up floating in space. They're not constrained to anything, so
it's a good idea to lock them before you try and apply any constraints. For example, if you're going to try and make something perpendicular, both lines are going to move if one of them isn't locked down to something. So you'll see several times through this, I lock the points and then I end up extending these lines so that they go all the way to the end of the implement. Now we get to start actually tracing. So we're going to use splines for this, set to fit. So all we have to do is press hard with the Apple Pencil, drop a point along the perimeter of the fork, and it's going to automatically fit a curve. And then we can always go back and adjust. So don't worry too much about getting it perfect right away. I'm going to set the control point for the end of the spline onto a perpendicular line to make sure that when we mirror across, it's going to be continuous. And then we're going to go back along and look for any places where either the control points should be adjusted or the actual center point on the fit curve should be adjusted, and we can get rid of any gaps along the perimeter. All right, now once we have the closed curves on this sketch, when you go into an isometric view, you can click on any of those blue faces and start to extrude them up and turn them into 3D shape. And then we're going to mirror them to make a solid body that represents the cut that we want to make out of our tray. The center line makes a nice flat plane when we extrude it, which gives us something that allows us to align the different utensils orientation north-south. And then we're going to organize them in a way that looks logical and draw a box around, extrude that up, subtract these solids that we made, and we've got a silverware tray. We need to add some clearance here. So after I do the subtract, I'm going to offset these faces 1 millimeter back. It's probably not enough, but I want to see how accurately we did on the tracing. After that, we're going to make a recess for you to be able to get your hands in and try and grab these, and add some blends for comfort. Sometimes these 3D prints can be pretty sharp on the corners. And let's pull it over into Prusa Slicer and see what it looks like. I'm going to use a Prusa MK3 Plus, which is a great little printer, but I'm realizing that it's actually too small for the size of this model. So let's see if we can pack this a little tighter and get it to fit on the bed. Okay, let's import this and see if we got it. Yeah, so it's about 5 millimeters clear on all sides of the bed. And let's go ahead and slice it and see what we end up with. So the slicing is probably the most important thing to be able to end up with a good quality print. It's showing an error here saying that there's a toolpath outside of the acceptable area for this printer. So the part fits, but there's they call it a skirt. There's like a couple layer border that they normally want to print around your parts. I think it's to make sure that the plastic is flowing well and that the Z height is about right all the way around where you're going to be printing, but we don't have clearance for that. So let's go turn that off in the settings. Okay, the slicing completed without any errors. Wow, almost 3 days of printing time. And let's go look. You can see some more details around, how many grams of material it's going to take, and some more details around the timing. There's so many settings here. It takes a little while to figure out what they're going to be, but it's not just, do I want to print at a 0.2 millimeter or a 0.15 millimeter height? There's how does the infill, which is the areas inside the solid object that make it so that it's not completely solid plastic all the way through. There's settings around the thickness of the top and bottom and how many perimeters are going to be printed. It's pretty fun to dig into it. It can be daunting, but that you can have a huge impact on how much time your print is going to take. So the first thing I'm going to change is the type of fill pattern. So gyroid takes longer. It's really cool looking, and it has uniform properties in all directions. But for this part, I think simple grid is going to be plenty strong and faster to print. The other thing I'm going to change is the combine infill. So this means that the infill will be printed thicker and only every other layer so that it can have way fewer tool paths. Okay, awesome. That one change pulled a day out of the print time and quite a bit of material. There's a bunch of time and material in external perimeters, but those are like the orange and yellow that you see on the screen that are the outside surfaces in XY. We can't reduce those below 2, which is all it's set to right now. So the other thing we can look at is the top and bottom layers, which are a reasonable amount of material, and there's multiple layers there. So let's reduce those a little bit and see what we get to. Okay, it's still a day and a half, but I think this is probably close to where we're going to end up. So I think I want to do some test prints and then maybe make some additional geometry updates, and we'll go see how we like it. For the first test print, I took a slice out of the middle of the CAD so that I wouldn't have to print the whole thing. And I've already learned some few things. All the pieces actually did fit, but you can see that they get jammed pretty easily, and they definitely need to have quite a bit of lead in to help them slip into the slots. So for the second test print, I added a little bit more detail and had a floor on the bottom of it and some lead in on the top. What you end up seeing is I must have made a mistake and eliminated the clearance that I had put in. So the larger ones didn't really fit, but I was still able to learn about how they slip in, and gave me some more insights. And I was able to go from there to update the CAD and prepare for the full show. So here goes. All right, it's done printing. It's amazing how a day and a half can feel like 30 seconds. Here we go. Moment of truth. We're going to bend the platen here so we can get it to pop off. Well, that was pretty easy. The print looks like it went really well. Here we go. It's got good profiles of all the silverware. Here's the big spoon. Looking good. Small spoon. We'll see about that. Yes. Like it. Small fork. All right, those are in there. All right, small spoon seems like not 100% success because it can get jammed going in there. We're gonna have to see if it like this, but otherwise, seems like it's working great. All right, let's go to the kitchen and see if we can load it up. Okay, this is the moment of truth. We have the 3D print. We have the drawer. You can see someone has spent the time to meticulously stack these in here, but I think that the tray we made is going to make this a lot easier. So, first of all, it does fit. These drawers are really deep. I built these cabinets during COVID, and I wanted to make sure that you don't have the problem where you can't get the drawer to close because everything's kind of packed in there. So I wanted to take advantage of that full height to make big stacks here. One of these clearly has been used to serve ice cream and is a different shape than the rest. Yeah, that's about as many as you probably have put in there right now. Okay, so there are a few more in the dishwasher, so this will fill up a little bit more, but that was the idea, that you got all your silverware here, you need a spoon, you grab a spoon. I mean, it's basically a silverware tray. Thanks for watching. Please like and subscribe, and I'll see you on the next one.